All right, everybody, this is lesson 8.5, the YouTube lesson, check for understanding. I apologize, I don't have my AirPods, so you're going to hear my pen on the iPad. So, this question is about Oreos. It says, for the second semester project, Ann and Tori wanted to estimate the average weight of an Oreo cookie to determine if the average weight was less than advertised. Okay. They selected a random sample of 36 cookies. So right there, that is N. And they found the weight of each cookie in grams. And then the average weight was X bar right here, 11.3921. That's pretty specific. With a standard deviation of SX. So this is the sample standard deviation. So check the conditions. They're listed up here. And I added the third one, which we also need to check. So is it random? It says, if we highlight, it says a random sample. Was it random? You could say stated in the problem, but yes, it was random. So check. Is it approximately normal? Now, remember, now that we are doing an average, sorry, don't know what I just did. We're doing an average. We're doing an X bar. So now we're doing the central limit theorem right here. Okay. There we go. I want that to. We're doing this one. The sample size has to be at least 30. So 36 is greater than 30. So we're good. That's the CLT, central limit theorem. Is it independent? Look at sample size was 36 cookies. So if I do 10 times 36, I got 360 Oreos. Oreos. Is that less than the population of all Oreos? Yes, definitely. They've made millions of Oreos. So I satisfied all three conditions to make a confidence interval for mu. All right, now we're going to create the 95% confidence interval. Here's the formula right here. So we're using an X bar, which they gave us right here. So this 11.3921, this is the center of my interval. And then I'm going to add and subtract this. This is the margin of error. So if you had a little diagram, I know that 11.3921 is the center. Okay. Plus or minus, okay, what in the world is T-star? We use a T-star when we are estimating averages or mu's because, well, it says here, Z-star if it's proportions, T-star if it's means. And so we have to look up on our packet the degrees of freedom. That's what this stands for. Degrees of freedom. Okay, and here's the idea if I go further back in the notes. The red curve here is for the normal curve, and that has z-stars, okay? But now that I'm finding an average mean, it has to be a little more conservative. I'm going to use this purple curve, which you can see is more spread out, which is going to like increase my standard deviation, okay? It's going to require us to use a larger critical value. The rationale is this, that when I'm doing a sample mean, I'm actually calculating two different values. I'm calculating the average, the mean, and I'm also calculating the standard deviation. And these two calculations, this and this, are not really related. They're different. Whereas when we were doing proportions, we had p hat and then we had the square root of p hat 1 minus p hat. You may recall this. These are both based off p hat. So essentially, I only have really one variable that I am estimating, so to speak. That one variable gets me the p hat and the standard deviation. But now with sample mean, I have this to calculate and this to calculate. So I kind of have double or twice as much that I'm trying to estimate. So to take that into account, the critical value for t's are wider. And then this purple curve will become taller and taller as the sample size grows. That's a long way of getting at this. So let me see here. We have 36 cookies. If I look up on the formula sheet, how do I do this? 36 cookies. Well, this is table B, okay? And see, DF is degrees of freedom. I'm trying to find n equals 36 down this column, but it's not there. I see 30 and 40. So you go up, okay? Round up or go up, okay? So for 36, go up to 30. So we're going to use this row, okay? And then what was our, I forgot, what was our confidence percentage? Oh yeah, 95% says right here, 95%. So 95% would zero us in, here's 95%, so we're gonna do this one, 2.042, okay? I just want to point something out here, so just keep an eye on this entire column, okay? The degrees of freedom is growing as you go down, and degrees of freedom is based on sample size. So as your sample size increases, what is happening to my critical value here? My critical value starts at 12. That's huge. And then it's 4, and then it's 3, and then it's 2. You can see it's shrinking as I go. And it is approaching, look at that, it's approaching my Z star, okay? Essentially, as your sample approaches a large enough size, as it approaches infinity, it will become the same as the Z star. So a smaller sample has a larger critical value because we are not as confident in our results. So we increase the critical value to move more standard deviations over or left or right. Anyway, long story short, this is our critical value for this question. 2.042. All right. Sweet. 2.042. SX was given to us up there. 0.0817 divided by the square root of the sample size, square root of 36. Okay. If we keep going here, break this down. If you take your calculator and let's get, what is this pink part? That is called the margin of error. It turns out to be plus or minus 0.0278. So the pink is the margin of error. Okay. MOE. And then on your calculator, you're going to add it and subtract it to the center. Okay, so 11.3921 plus 0.0278. So that would be the high end of the interval, 11.4199. And then repeat that again and just back up and change it to minus. So I've got 11.3643. And again, this and this are 0.0278, the margin of error. So that's my interval. In interval notation, it would be this. And we could write a sentence. We are 95% confident that the true weight of an Oreo cookie in grams is between 11.3 blah 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 grams and 11.4 blah 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 grams. All right, number 3, last one. On the packaging, the whole thing we were doing here is they were wondering if the weight was less than advertised, if the Oreo company is cheating all of us. The stated serving size is 3 cookies at 34 grams. Does the interval that we got provide evidence that the average weight of a cookie is less than advertised? So 34 divided by 3, that's because there were sample servings of 3, is 11.3 repeating. Okay, this is what is advertised. Is 11.3 in our interval? Okay. It's not. So you might be like, "Oh, what's wrong?" They're advertising essentially that it's 11.3 repeating, which is lower than this entire interval. So in fact, the average we got is above what they're advertising. So are they is the average weight less than advertised? No, it's not less than advertised. No, in fact, our data suggests the opposite. Suggests that the average weight of an Oreo, of a single Oreo cookie, is above 11.3 repeating grams. Because, why is that? Because our entire interval, I should say our entire confidence interval, is above 11.3 grams. So essentially we are checking what the claim is against our interval. All right, folks, bye-bye.